Welcome to The Explainer. Today, we are tackling one of the biggest, deepest mysteries in all of science. It all comes down to a single, kind of random-looking number that, believe it or not, defines the very fabric of our reality. It's everywhere, it's everything, but for 100 years, nobody has been able to explain why. So what is this number? It's approximately 1 over 137. I know, it doesn't look like much, right? But this one little constant is basically the universe's master controller. It sets the rules for how light and matter interact with each other. It's the reason atoms can stick together to form molecules. It's why chemical reactions happen. It's even why stars can shine. And that, of course, leads us to the biggest question of all. Why that specific value? Why not 136 or 138? Why is our entire universe tuned so precisely to this one odd little number? You know, it's a question that has kept the greatest minds in physics up at night for more than a century.
Now, this magic number actually has a proper name. It's called the fine structure constant, and we usually represent it with the Greek letter alpha. The best way to think about it is like it's the universe's master volume knob. It sets the strength of the electromagnetic force, which is the fundamental way that light and matter talk to each other. And this is where the puzzle gets really, really deep. All of our best, most successful theories, I'm talking about the standard model of particle physics, the whole shebang, they just take this number as a given. They plug it into the equations because, hey, it works. But they offer absolutely no explanation for where it comes from. It's just a brute fact we've measured in experiments, not something our theories can actually predict.
So how does mainstream physics define alpha? Well, when you look at the official equation, you start to see the real heart of the problem. Honestly, this is where we just hit a brick wall. This is the textbook formula for alpha. But look closer. It's not really an explanation, is it? It's more like a recipe made from other fundamental constants. You've got the charge of an electron, a constant for empty space, Planck's constant from quantum mechanics, and the speed of light. The problem is, we have no idea why any of those have their specific values either. It's like trying to solve a riddle by just giving another riddle as the answer. It's a totally circular argument. And this really lays out the two completely different ways of seeing reality. On one side, you have the standard model view. Our universe is built on a collection of fundamental, totally unexplained numbers that we just have to accept. But on the other side, there's a radical new idea called vacuum pulsation curvature theory. Let's just call it VPCT for short. And this theory says, hold on, what if these constants aren't fundamental at all? What if they actually emerge from the properties of empty space itself? So let's dive into the core idea of VPCT. It proposes something pretty revolutionary, that the constants of nature aren't just random numbers that were set at the Big Bang. Instead, they're properties that bubble up from the vacuum of space itself. This theory suggests that what we call empty space is anything but empty. Okay, VPCT describes the vacuum as this dynamic, complex field. Now, I know this equation looks super intimidating, but you can totally ignore the math. Just focus on those two Greek letters, rho and theta. These two things represent the two key properties of the vacuum, and they are the secret ingredients to, well, everything else. So these two components are our building blocks. First, you have the amplitude, rho. That gives the vacuum its stiffness, its resistance to being curved, which is related to gravity. Then you have the phase, theta. This describes its quantum nature. You can picture it as little twists or vortices in the vacuum field that actually give rise to things like electric charge. So the really crucial point here is that VPCT isn't just trying to add a new particle or another force to our old theories. No, it's proposing a completely different way of looking at reality. It's suggesting that the universe's most fundamental rules are just the collective behavior of this underlying vacuum field. It's a whole new rulebook. Okay, so if the vacuum is this dynamic field, what does that mean for all those so-called fundamental constants we talked about? Let's take a look at how VPCT rebuilds them from the ground up, starting with the ingredients of that original circular equation for alpha. And this is absolutely mind-blowing. The speed of light is no longer just some universal speed limit. It's the speed of a wave traveling through the vacuum, and it's determined by that vacuum's stiffness and density. Electric charge isn't some magical property particles just have. It's a literal physical twist in the vacuum's phase. All of a sudden, these numbers that were once just mysterious givens now have a real physical origin. And all of this whole new way of thinking, leads us to the breakthrough moment. By redefining all the ingredients, VPCT can finally give us a physical explanation for that magic number itself. This is the big reveal.
So by combining these new vacuum-based definitions, VPCT comes up with a totally new equation for alpha. And again, don't worry about the symbols. What's important here is the new term B. It represents the vacuum's phase stiffness, which is basically just a measure of how much the vacuum resists being twisted or wound up.
But here's what that math really, truly means, and this is the key insight right here. Alpha, our fine structure constant, is simply the ratio of how rigid the vacuum's phase is compared to how rigid its amplitude is. It's a structural property of space-time itself. For the first time ever, we have a physical meaning for 137. It's not some random number that nature just dialed in. It's a direct measurement of the mechanical properties of the vacuum. It tells us the relationship between two different kinds of stiffness in the very fabric of reality. Okay, now it's really important to be clear about what this theory can and can't do, at least not yet. It provides an incredible, powerful physical meaning for alpha and shows how it can emerge from the vacuum. What it can't do, so far, is predict that exact value of 1 over 137 from scratch. And that, my friends, is the next big hurdle. So how do we know if the theory is even on the right track? Well, physicists can run what's called a consistency check. They take the number we already know, about 1/137, and they work backward to figure out what the properties of the vacuum would have to be to produce that number. And what they find is that the results they get for things like the vacuum's stiffness and density, they're totally plausible. They line up with other measurements we have of the cosmos. It all fits together. So what's next? How does VPCT go from being this really elegant explanation to a full-blown predictive theory that we can actually test? Well, there's a clear roadmap. The theory needs to get to the point where it can calculate these vacuum properties, the stiffness, the density, from its own basic principles, without having to plug in any other measured numbers. If it can do that, and if the final calculation for alpha spits out a number that's really, really close to 1/137, well, that would be one of the greatest achievements in the history of physics. No exaggeration. But even right now, in its current form, VPCT's contribution is just huge. It gives us a single, unified framework that provides a physical origin for electric charge, for the speed of light, and for quantum mechanics, all while explaining the mechanism behind alpha. It connects electromagnetism, quantum theory, and even gravity through the mechanics of the vacuum. So the crucial takeaway is this. Our universe's fundamental rules might not be arbitrary at all. They aren't just magic numbers or random cosmic settings. They could be the direct, logical, and maybe even the inevitable consequence of the physical properties of what we used to call empty space. For centuries, we've searched for the universe's code in the things, in particles and forces. This new perspective suggests maybe we should have been looking at the space between them all along. It leaves us with this incredible thought. Is the universe's most fundamental code written in the physics of nothing at all?